Welcome students. We are learning definite integrals, and till now what we have learned that there are two methods to find out value of a definite integral. One is by limit of sums and one is by using antiderivatives. We have seen that there are definite integrals whose integrand is very simple, so that antiderivative of small f(x) exists, and therefore you can write the value in this form. So, but there are several integrals where f(x) is very complicated. In that case, say, so this is very complicated function whose antiderivative is difficult to find. Compute antiderivative. I find out f dash x such that this is equal to small f(x). Then what we have seen that we apply in these cases, we apply method of substitution. Method of substitution. And what we do in this, that we transform the integral where we will have new limits. These limits will be different, and we get another function which is simple enough to compute antiderivative. That is, there exists g dash t such that there exists gt such that this is equal to small gt. Then we have also seen that there are 7-8 properties of definite integral. If you use these properties of definite integrals and evaluate the integral, life becomes much simpler and you can compute the integral much easier than otherwise. So, you are supposed to understand the properties, prove it, and then try to apply it on definite integrals to evaluate complicated definite integrals. Then there are a lot of applications of definite integrals, and as an application we have started computing area of certain shapes, and we started with very simple shapes, like we have computed area of circles, ellipses, and we have also computed area of a curve bounded between the curve and a given line. In this sequence we proceed further and solve some more problems to understand the definite integral in a much better way. So, let us take another example. So, find out smaller area bounded between ellipse and vertical line x equals to AE, where A is greater than B. So, let us plot ellipse and this line. If this is your x axis and this is your y axis, then since A is greater than B, so let us say that this point is minus a comma 0 and this point is a comma 0 and this is 0 comma b and this is 0 comma minus b. Then you can plot the ellipse like this, and you know that the AE is coordinate of the focus, one of the focus of ellipse. So, say this point is AE comma 0. So, the vertical line that is given to you is this. So, since we are looking for a smaller area bounded between the ellipse and this line, so the required area is this. Again, you know that ellipse is symmetric both about x and y axis because powers are even. So, it is symmetrical about x and y axis, therefore, this area is symmetrical about x axis. So, required area is area shaded by green color, say this is A. So, required area is equal to twice into area of shaded by green color, this is equal to 2A. So, now if you consider a vertical strip here with whose width is dx and height will be governed by the equation of the ellipse. So, elementary area will be y dx, and if you integrate it from x from minimum to maximum, that is x equals to AE to x equals to A, you get the required area. So, if you solve the equation for y, you get two values of y, that is 1 minus x square by a square under root plus minus b. Since we are using upper portion, the portion of the ellipse which is lying above x axis, therefore, we will be using this equation, a square. So, therefore, y is b by a under root a square minus x square. So, required area is therefore 2 AE to A b by a under root a square minus x square dx. Let us solve this integral and get the value. We get 2 b by a AE to A under root a square minus x square dx. So, we can write, this is a well known integrand and its value is known to you. So, you can write the value directly. So, value of this integral will be limit goes from a to a. So 2b by a, at a it will give you 0. So value of this function at a minus value of this function at a. So at a it will be 0 plus 1 by 2 a square sine inverse 1 minus half a under root a square minus a square e square plus 1 by 2 a square sine inverse e. So we get 2b by a, sine inverse 1 is pi by 2, so we get pi a square by 4 minus 1 by 2 a e. This value you can replace by b, because you know that b square equals to a square minus a square e square for ellipse. Sorry, there will be a negative sign over here, please correct it. So we get minus 1 by 2 a square sine inverse e. So this is the answer of the problem that is given to you. So let us take another example and see how to compute area bounded between two curves. For that, let us say case 1, assume that fx is greater than or equal to gx for all x in the interval ab, and they coincide at the point a and b. So if this is your y axis, this is your x axis, so you can plot fx and gx in like this, where this point is say a and this point is b. So you assume that fx and gx, they have same value at a and b, but fx dominates gx in the interval a to b. So area bounded between these two curves is this. Now how to compute this area? So divide this area into several very thin rectangles, are known, that is also referred as elementary area, and see if you just extend it to here on x axis, say this is dx. So area of this elementary strip will be this height into dx, and this height will be fx minus gx. So height is this into dx gives you area of this strip. Now if you integrate it, so this is your elementary area for this area, for this required area, this is fx, this is gx. So if you integrate it from x equals to a to b, you get your required area. we can understand this example in a different way also and derive this formula. For that, let us draw the figure again, and fx, this is gx, this is x axis, y axis. So, first let us compute this area. So, value of this area will be, if you take this vertical strip, you get fx dx, this is A and B. So, you get, this gives you this area shaded by green color. Now, if you take this vertical strip which starts from 0 and ends on gx every time. So, if you just integrate this, you get this area. So, if you take gx dx is area of this strip, and if you integrate from A to B, you get the red area shaded by red color, and A to B fx dx is area shaded by green color. So, if you subtract them, you get the required formula. So, we have computed first green shaded area, which is given by this integral, and then we have computed red shaded area, which is given by this, and if we subtract, we get the required area shaded by blue, and so we get this formula finally. Let us take another case 2, where fx dominates gx when x belongs to A to C, AC close interval, and gx dominates fx when x belongs to CB. And the situation can be represented graphically as following. So, we have fx and gx, this is point C, this is A and this is B, and we are looking for this area. This curve is fx, this is gx. So, let me draw it by different colors so that it is clear to you. So, from A to C fx dominates and from C to B gx dominates. In this case, by applying the previous formula, we can get required area as A to C fx minus gx dx plus C to B gx minus fx dx. For red shaded area, elementary area is this, because fx dominates. So, elementary area, that is area of elementary strip or thin rectangle, is fx minus gx into dx, and for green shaded area, elementary strip is this, and elementary area will be given by Gx minus Fx into dx. Now, let us apply this formula and solve some problems. So, find out area bounded between y square equals to 2x and y equals to 4x square. Let us draw the curves. So, let us see what region we are getting. For that, you know that y square equals to 2x is a parabola whose vertex is 0 0 and axis is x axis. So, you get this, and y equals to 4x square is a parabola whose vertex is 0 0 and axis is y axis. Therefore, it will be drawn like this. So, area bounded between these parabolas, elsewhere they will not intersect each other. So, area bounded between these parabolas will be, now what we do, we divide this area into elementary area. So, if we assume that width of one such elementary rectangle is dx, then elementary area for this region will be, this is your y square equals to 2x and this is your y equals to 4x square. So, root 2x y square, this is y square equals to 2x. So, this is actually root 2x and this is 4x square. So, elementary area will be root 2x minus 4x square into dx. So, to find out this integral, we need to find out the point of intersection of both parabolas. So, to do that, let us compute the intersection of both. So, if you substitute y here, you get 16 x power 4 equals to 2x. So, that will give you 8x cube minus x equals to 0. So, point of intersection, by solving this you will get x equals to 0 and so you get x cube minus 1 into x, you get x cube 8x cube minus 1 in one bracket into x. So, you get x equals to 0 and x equals to half. So, one point of intersection is 0 comma 0, another point of intersection is half. If you put half here, you get 1. So, another point of this is half comma 0, the point of intersection is half comma 1. So, the limits of integration will be from minimum to maximum, that is x equals to 0 to x equals to half. Now, let us integrate it. So, you get root 2 0 to half minus 4 x cube by 3 0 to half. So, we get 2 root 2 by 3 1 by 2 1 by root 2 minus 4 by 3 into 1 by 8, which is equal to 1 by 3 minus 1 by 6, this is equal to 1 by 6. So, required area is 1 by 6. Let us take another example. Find out area of the region which is outside parabola y square equals to 4x and inside the circle x square plus y square equals to 8x. So, this equation of the circle can be written as x minus 4 whole square plus y square equals to 16. So, draw x and y axis. Remember one thing, that in solving all these problems you should be very good in plotting. So, this is a circle with center 4 comma 0 and radius 4. So, you get the circle and this parabola will intersect the circle. So, we need to find out that. So, x square plus 4 8, replacing y square by 4x here, we get 8x. So, x square is 4x, x minus 4 is 0. So, x equals to 0, x equals to 4. So, the parabola intersects the circle at x equals to 0 and x equals to 4. So, parabola will be drawn like this. So, you are supposed to find out the area of the region which is outside the parabola and inside the circle. So, your required area is this. Now, since this circle is symmetrical about x axis and parabola is also symmetrical about x axis, this required area is also symmetrical about x axis. So, required area will be, if say this area is A, so this area will also be A. Required area is twice of A. Now, if you assume that this is the elementary strip, let us compute this area which is lying above x axis, which is outside the parabola and inside the circle. So, if this is the strip elementary area of dx length, height will be value of y from circle minus value of y from parabola. So, your elementary area will be y from circle. So, you need to solve it for y. So, you get 16 minus x minus 4 square, and you get plus minus, and y equals to plus minus root 4x. So, elementary area will be, because you are using the curves above x axis, so you will be using 16 minus x minus 4 square minus under root 4x. So, this is your elementary area, and limit will be from x equals to 0 to x equals to 4. Let us compute it further. So, substitute x minus 4 equals to t in this part of the integral. You get the limit will at x equals to 0, limit will be t limit will be minus 4, and x equals to 4 t limit will be 0, and you get here 16 minus t square dt, and this integral we can write as it is. So, this will be equal to 1 by 2, value of this integral will be 1 by 2 t under root 16 minus t square plus 1 by 2 16 sine inverse t by 4 minus 2 minus this limit from here is minus 4 to 0, and limit here will be from 0 to 4. So, you get 0 here, then 0, then at minus 4 again it is 0, then minus 1 by 2 into 16 is 8, sine inverse minus 1 minus 4 by 3 to 4 to the power 3 by 2 minus sign is also plus 0. So, finally, you get the value of this is minus pi by 2. So, you get 4 pi minus 4 by 3 into 8. So, final value is 4 pi minus 32 by 3. This is your final answer. So, this is area which lies above x axis. So, required area will be twice of this. So, you get 8 pi minus 64 by 3. Let us take another example. Find out area bounded between circles x square plus y square equals to 4 and x minus 2 square plus y square equals to 4. Let us draw both of them on Cartesian plane. So, this first one x square plus y square equals to 4 is a circle of radius 2 and center 0. So, you get this, and this is point is 2 comma 0, and this is also a circle with center 2 comma 0 and radius 2. So, you get this circle. So, the common area between these two circles is this. To find out this, let us divide this area into horizontal, very thin horizontal rectangles like this, and say this is dy, width of one horizontal strip is dy. So, elementary area will be, x goes from here to here. So, we need to find out equation of this portion of the circle, we need to find out equation of this portion of the circle and this portion of the circle. So, equation of this portion and this portion. So, equation of this portion, if you solve it, x square plus y square equals to 4, you get x as plus minus under root 4 minus y square. So, equation of this will be 4 minus y square. Similarly, you solve this equation for x, you get x minus 2 is plus minus 4 minus y square. So, x is 2 plus minus under root 4 minus y square. Now, if you solve this for x, you get two branches, and so if you draw this vertical line, 2 plus under root 4 minus y square represents this portion of the curve. I repeat, 2 plus under root 4 minus y square represents this portion, green colored portion of the circle, and 2 minus under root 4 minus y square will be represented by this red portion of the circle. So, the equation of this red portion is 2 minus under root 4 minus y square. So, therefore, elementary area is this minus this into dy. So, that is 4 minus y square minus 2 minus 4 minus y square into dy, which is equal to twice of 4 minus y square minus 2 dy. So, required elementary area, if integrated, you get the actual area, that is integration of 2 under root 4 minus y square minus 2 dy, y from minimum to maximum. Again, we need to solve equation of both the circles to get this limit. So, to solve that, if we put y square equals to 4 minus x square over here, 4 minus x square equals to 4, we get the point of intersection. So, x is 1. So, at x equals to 1, y is plus minus root 3. Put x equals to 1 here in either of the equations, say put x equals to 1 in this equation, you get y as plus minus root 3. So, this is minus root 3, y equals to minus root 3, and this is y equals to plus root 3. So, the limit of the integration will be from minus root 3 to plus root 3. Well, let us solve this integral. This is, you can see that this integral is from minus a to a f(x) dx type. where this integrand is even function of y. Therefore, you can write this as 0 to root 3 twice of 0 to root 3 to 4 minus y square minus 2 dy. So, this is equal to 4 0 to root 3 that will be equal to 4 1 by 2 value of the integral 0 to root 3 under root 4 minus y square dy will be one by 2 a square is 4 sine inverse y by 2 minus integral of this one is y 0 to root 3. Let us evaluate this and get the final answer. So, we get this is equal to 4 1 by 2 root 3, this is 4 minus y square is 3. So, you get 1 plus 2 sine inverse root 3 by 2 minus at 0 it will be 0, at 0 it will be 0 and this also will be 0. So, we get this. So, 4 2 this is pi by 3 minus root 3. So, we get 8 pi by 3 8 pi by 3 minus 2 root 3. This is the final answer. Now, let us take another simple example of a function which changes its sign and lies above and below x axis and see how the area can be computed. Let us take a simple example. Find out area bounded between x axis, sin x and x equals to minus pi by 2 to x equals to 3 pi by 2. So, let us draw the curves. Say this is minus pi by 2, this is pi by 2, this is pi, this is 3 pi by 2. So, sin x will exhibit approximately this kind of property, which is the usual property of sin x. So, you get this curve. So, the required area is A1, A2 and A3, summation of all three. So, your required area, let me shade it. So, required area is this plus this plus this. Since A1 and A3 they are lying below x axis, so they will be having negative value. So, required area is equal to modulus of A1 plus A2 plus modulus of A3. So, A1 is minus pi by 2 to 0 sin x dx, integration of sin x is minus cos x minus pi by 2 to 0 . minus 1, A2 is 0 to pi sin x dx, which is minus cos x 0 to pi. So, you get 1 minus 1, which is 2. A3 is pi to 3 pi by 2 sin x dx, which is equal to minus cos x pi to 3 pi by 2, which is equal to minus 1. So, required area will be is equal to 4. Let us take another example. Find out area bounded by mod x plus mod y equals to 1. So, if you examine carefully, this equation represents 4 curves, x plus y equals to 1, minus x plus y equals to 1, x minus y equals to 1, and minus x minus y equals to 1. So, let us plot them. This is in the first quadrant, minus x plus y. So, x is negative, y is positive. So, this is in this line. So, minus x plus y equals to 1. This is x plus y equals to 1. X minus y is this line, x minus y is 1, minus x minus y is equal to 1 is this one. So, the required area is therefore this. Let us divide this area into thin vertical strips like this. So, what you can see is for this portion, which is on negative side of x axis, the elementary rectangles start from this line and finish on this line. For this portion, which is on the positive side of x axis, they start from this line and finish on this line. So, we need to break this total integration in two parts. So, we will be computing the area shaded by black and area shaded by red separately, and then we will add it. So, for black shaded area, elementary area will be, if you take dx as width of the strip. So, dx will be y is 1 minus x minus, here y is x minus 1 into dx. The limit of x will be from here to here. So, by observation you can see that this will be 1 comma 0, this will be minus 1 comma 0, and this is origin as usual. So, the limit of this integration will be 0 to 1 plus, for red shaded region, for this if you take dx as width of elementary strip, elementary rectangle, elementary area, whatever. So, limit will be from minus 1 to 0, and elementary area will be y is 1 plus x minus y is minus x minus 1 to dx. Fx minus gx, try to recall the formula we discussed earlier. So, we get 0 to 1 2 1 minus x dx plus minus 1 to 0 2 1 plus x into dx. This is equal to 2 1 minus x is square by 2 minus 0 to 1 plus 2 1 plus x is square by 2 minus 1 to 0. By putting the limits, we see that we get, for upper limit this value is 0, then minus lower limit will be giving you 2 into minus half plus upper limit again will be giving you value, lower limit will be giving you 0. So, we get 2 into half again. So, we get 1 plus 1 which is equal to 2. So, total required area is 2. Let us take another example. So, example is, find out area bounded between the curves y square equals to 4ax and y equals to mx. We need certain conditions on a and m so that we can at least plot these curves properly. So, we assume that a is 0 and m is also positive. So, we will solve this problem in our next lecture. With this I stop, and later we will consider some more complicated problems and explore more about definite integrals. Thank you.